All right, so we're back and we're going to do a part two, which kind of walks you through another way to approach it. This one should be what you should expect to do for, I don't know, tomorrow. So here's what we have. We have a graph given to us, which represents velocity based off time in hours. The velocity is kilometers per hour. And I want to figure out the distance traveled between 0 and 12 hours. So if I think about what I'm given, I know that velocity is usually found by taking the distance and dividing it by time. Another way to think about that is I can take velocity multiply it by time in order to find distance. Right? So since I know what the velocities are and I know the times, I can use that approach to find the distance that was traveled between that amount of time. So if I think about what the question is asking me, it's asking me to do this. I need to go ahead and the distance should equal the integral starting from 0 hours all the way to 12 hours of the velocity equation given to me based off the time. So that's what this is asking me to find. And the way I'm going to do it is by, since I don't have an equation, just take the velocities multiplied by time. In the last video, I was talking about making rectangles. Because usually if we can make rectangles, they're very easy to find. But because I have such straight lines, I can do this a couple different ways. I'm going to break this up into a couple shapes. So this one will be a trapezoid. Right? And then I'm going to make myself a little rectangle. And then I'm just going to finish off by having a triangle. All right. I've taken the original graph, now I've made it into 3 shapes. I should know how to find the area for each of those 3 shapes, and if not, well, I can find those formulas real quick by using the internet. So let's start with the trapezoid. So the trapezoid, here's the version of the equation I know. It is 1/2 the sum of the bases multiplied by the height. Right? So what I'm going to consider base 1 is from here to here is base 1. And from here, here all the way up here will be base 2. And my height will be from here to here. So I'm just going to take those numbers and plug them in. So this is from 0 all the way to 5. This is from 0 all the way to 8. And the height is from 0 all the way to 6. So I have that. Right? So according to the trapezoid equation, from 0 to 6, the velocity multiplied by the height based off time to get me the distance from 0 to 6 should be the same as if I had 1/2 times 5 plus 8 multiplied by 6. And doing those calculations in my head gets me 39 kilometers, right? Because if I multiply the units, kilometers per hour by hours, I just get kilometers. So I know that from 0 to 6, that's 39 kilometers so far. Okay, so keep it going. And we're going to talk about that rectangle. So the distance according to the rectangle covers from 6 hours to 8 hours the velocity multiplied by the change in time. So for that, I just need base times height. So the base, okay, so this one I'm going to reorient. I'm going to say the base is 2 because traditionally when we talk about integrals and finding the areas of a graph, the base is this and the height is from 0 to 8, so that's 8 right there. So it's a 2 by 8 rectangle. Right, so that distance should be the same as 8 times 2, which should be 16 kilometers. All right. Oops. So I know that from 0 to 6 was 39. From 6 to 8 is 16 kilometers. So now we're in the final stretch. And we need to talk about that rectangle. Oh, wow, that triangle, geez. So for that triangle, it covers that little last stretch. It's from 8 to 12 hours. Right, and I'm just writing this all out to get you comfortable with the notation and showing you what each of these color-coded ones represent in terms of the distance covered from what time to what time, okay? Which should be the same as 1/2 base times height. So, luckily I know my height is already 8, and my base goes from 8 goes from 8 to 14. Sorry, 8 to 12. So that'd be the same as my touchscreen crapped out, and I'm just gonna power through this. So it'd be 1/2 base, which is 4 times 8, which is my height. So that one should be 16 kilometers as well. Interesting. Okay. So to recap what we've done, I figured out the area of this entire shape by breaking it into a couple different shapes, the trapezoid, the rectangle, and the triangle. So to figure out the question right here in the black, well, that's just the same as adding the trapezoid. So from 0 to 6, of the velocity. And you'll forgive my slow writing, but it's the best I can do right now. Plus that of the rectangle, which is from 6 to 8 actually. 6 to 8 of the velocity function. Plus the triangle. Which means I'm starting from 8, going all the way to the 12 hours. That's my upper bound, and the 8 would be my lower bound. V of t dt all right. So if I add them up, whatever I get would be the answer to this question. And if I look back at the numbers I had 39, which you can see in the bottom left right there. That's highlighted. I have the 16. I have the 16. So 39 plus 16 would be, let's see, 16 plus 16 is 32. 32 plus 39 makes it 71. So it turns out that this raft traveled 71 kilometers. So when you're finding an integral, you can break it up into smaller pieces if it helps you find the area underneath the curve a little better. Hope this helps.